Presentation.
Direct. Yeah. Otherwise, directly, if they want to ask you, they may.
Okay.
We will give them the opportunity, sir.
Okay.
Okay. Okay.
Sir, Akila would be taking care of Mohan, sir.
Okay.
Akila would be taking care of the live streaming, so she will not be able to compare it. So I will do that.
Okay. 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 Start பண்ணு. Start.
இல்ல சார்
yes.
இன்னும் எனக்கு கொஞ்ச நேரம் வெயிட் பண்ணலாம்னு பார்த்தேன் 35.
Yeah, another 10 minutes wait பண்ணு.
Yeah, that's what. 3 minutes we'll wait, sir. Suddenly the participant starts leaving. I know why.
Yes, that is the wondering
How many participants do you have right now?
We only have around 10, sir. So they may be joining.
YouTube, some people have already joined.
Yeah, okay. Sir. Shall I start, sir?
Yeah, we can. Yeah, we'll start.
Yeah. Greetings and good evening. On behalf of the organizing units IEEE CS Madras chapter, CSI Chennai, ACM Chennai, and Hindustan Chamber of Commerce HCC, I'm happy to welcome the speaker, the chairs, and office bearers of organizing units, delegates, and the participants present in Google Meet and YouTube live streaming as well for today's webinar on the fourth industrial revolution and 100 years of AI from 1950 to 2050. Now I welcome Mr. Linesh, SanatKumar, President, Hindustan Chamber of Commerce, to deliver the welcome address. Please, sir.
Yeah. Good evening, ladies and gentlemen. I have great pleasure in welcoming you all for this important webinar organized by the Information Technology Committee of our chamber, headed by Mr. H.R. Mohan and his team. This is a joint webinar with IEEE, Computer Society of India, and ACM Chennai. I once again would like to congratulate H.R. Mohan for initiating such important webinar for the benefit of our members, along with Dr. Komathy and Dr. Sakthivel, and both are from the CSI and from the ACM, for conducting such fantastic programs. I think every 2 or 3 weeks we are having such programs. I'm also happy, and we have an eminent speaker, Dr. Alok Aggarwal, founder and CEO of Scry Analytics Inc. USA, who's going to give us a presentation on the topic, the fourth industrial revolution and 100 years of AI. I welcome you, sir, for today's program, and also thank you for being associated with our activities and initiatives which have been taken. As I understand, sir, third industrial revolution started in 1950, and then we moved on from, that's when we moved on from the analog to digital. It was also called the digital revolution at that time. And after almost 65 years, we have now moved on to a fourth industrial revolution, wherein the IoT, big data, cloud computing, robotics, cyber security, etc., are changing workspaces and also changing our lifestyle drastically. I suppose the fifth revolution is also not very far the way things are moving. And we welcome you again once, sir. And I personally look forward to Dr. Aggarwal's presentation. And I'm sure it will be an enlightening one for all the participants this evening. Welcome, one and all. I hand over the proceedings to the MC today.
Thank you, sir. So now I welcome Mr. H.R. Mohan, sir, Chair Events Computer Society of IEEE Computer Society, to introduce a speaker. Please, sir.
Yeah. Good evening, and once again, let me welcome everyone for this program, wonderful program. Our special welcome to Dr. Alok Aggarwal, who is in early morning, 5 a.m. at US. He has taken so much of interest in joining us in the early morning, 5 o'clock at US, and joining for this webinar presentation. Thank you, Dr. Aggarwal. So welcome once again. We welcome you. And all of us know that the industrial revolution has been witnessed in so many forms, and we are in the fourth industrial revolution, and which is managed by most of the automated things, including the IoT and blockchain, metaverse, robotics, and autonomous vehicles, and including in the health sector, the gene editing, protein folding, personalized health, and quantum computing, and climate changes. So today's webinar going to be in 2 parts. In the first part, we'll be having Dr. Aggarwal to discuss about the 8 vital characteristics of previous industrial revolutions and how they are manifested to the current one. Indeed, these characteristics are going to be extremely useful in understanding the phase and scope of the current revolution and imagining the possibilities that may unfold during the next 3 decades. In the second part of the webinar, Dr. Aggarwal will discuss about the recent successes and shortcomings of deep learning networks, which include generative pre-trained transformers and large language models. Also, he will discuss few novel and unique use cases where AI is being used or will be used very soon. These are going to be extremely helpful in comprehending the depth and breadth of AI's explosion. It may be noted that today's talk is based on a couple of chapters from the book titled The Fourth Industrial Revolution and 100 Years of AI between 1950 and 2050, which was authored by Dr. Aggarwal. Now, let me formally introduce our eminent speaker. Dr. Alok Aggarwal received his PhD in computer science from Johns Hopkins University. He worked at IBM T.J. Watson Research Center near White Plains, New York, during 1984 and 2000. In the fall terms of 1987 and 89, he took sabbatical to teach 2 courses and supervise PhD students at MIT. In 1993, he and his colleagues built a supply chain management solution for paper and steel mills. This was the first commercial AI-based solution of its kind. Madison Paper Company, based in Miami, was the first one to buy the solution in the year 1993 and use it until the company was sold to others in 2017. In January 1998, Dr. Alok founded the IBM's India Research Laboratory inside his alma mater, IIT Delhi. And within 2 years, he expanded it as a 60-member team, of which 30 PhDs and 30 masters engaged in the research wing of IBM in India. In January 2001, he co-founded EvalueServe, which has more than 4,500 employees and provides various kinds of knowledge processing services like research, analytics, and consulting services. His first article in the year 2003 wrote on the subject knowledge process outsourcing led to a new subsector of outsourcing that currently has more than 300 companies worldwide. In February 2014, Dr. Aggarwal founded Scry Analytics that performs research and development in artificial intelligence and data science and has produced 5 products and distributed platform for Internet of Things. Dr. Aggarwal has published over 120 research articles, has been granted 8 patents from the US Patents and Trademark Office, and has been the editor of several academic journals in computer science. Recently, he has published the book titled The Fourth Industrial Revolution and 100 Years of AI, which is now one of the bestsellers in Amazon. And today's talk is going to be based on the book, what he has written. With this brief welcome note and the introduction to the topic and the speaker, now let me welcome Dr. Alok Aggarwal to enlighten our participants on the Fourth Industrial Revolution and 100 Years of Artificial Intelligence. Vote Dr. Aggarwal, please.
Thank you, Mr. Mohan. Thank you. And I unfortunately did not have the right to upload the presentation. So if somebody can give me the right to allow to share my screen, I would be happy to do so. Okay.
No, sir. You can present, sir.
Yeah. Hopefully everyone can see it. Unfortunately, I may not be able to cover both of the parts that Mr. Mohan talked about because even the first discussion on the Fourth Industrial Revolution may take about 40-45 minutes, and we may only have 15 minutes of question answers. So if it's okay with everyone, I'll probably just cover the Fourth Industrial Revolution and 100 Years of AI, which is the first chapter of the book, as Mr. Mohan had said. And then perhaps we can have another discussion on AI and both the limitations of current machine learning systems of AI, namely transformers and large language models, as well as deep learning networks in general. sometime later, maybe a couple of months down the road. So with that, let me start with the first chapter, which I found actually very interesting. In fact, it took me the most time to write this chapter because I did not know much about industrial revolutions when I started. And I found it quite fascinating as to why and how these industrial revolutions start. But just before that, talking about the book has 17 chapters and one appendix. The book does not have any software code and very little math. The math is restricted to linear equations of the type 3x plus 5y equals 7. And there is a dynamic list of about 1,150 use cases on our website, which you can go and check it out if you're interested as to what is happening in the area of AI and how much will happen in the near future. With that, let me start with the 8 vital characteristics of the fourth industrial revolution, which I mentioned is chapter 1 of the book. So the first characteristic, and there may be, by the way, many more, these are, these are the characteristics I found during my research. And I was kind of surprised that nobody had talked about what makes an industrial revolution a revolution. Why is not every decade an industrial revolution? Or why are industrial revolutions anywhere from 4 decades to 8 decades? So by no means are these 8 characteristics the only characteristics. I'm fairly sure there are many others, but let me start with these 8. So the first characteristics is each revolution has had many inventions simultaneously. For example, the first revolution started with the steam engine, but then there was spinning jenny, water frame, spinning wheel, small machinery doing textile knitting and so on and so forth, a part of which was spinning jenny. A complete new infrastructure got formed because everything or most of these things were dependent on steam engine. So there was a complete infrastructure of canals and waterworks, and then steam infrastructure got formed in the first revolution, which lasted for almost 8 decades, 1760 to 1840. The second revolution, which started in 1870 primarily and lasted till 1914, had electric trams and railways. Railways had started with steam engines, but they only took off in 1870 with massive amount of infrastructure for railways being created. Telephones, telegraphs, of course, we know the cars and vehicles got created with Ford coming in and creating mass creation and distribution of cars. Incandescent lamp, internal combustion engine, which led to development of vehicles. The typewriter that we know today, QWERTY, because of the letters QWERTY at the top left. The mass production of goods, electric motors, and electricity infrastructure. The interesting part is the infrastructure here. In fact, there were 2 infrastructures formed, one of electricity and one of actually moving petrol around or oil and gas around so that people could buy petrol from petrol stations and also cooking gas, either from coming to their homes or at that particular point coming in cylinders. And then electric motors, right? It lasted till 1914. Just after that, actually, the First World War started. And the second revolution that one of the speakers talked about was the analog to digital revolution, was the third revolution, where the first actually electronic computer got created. It was called ENIAC, Electronic Numerical Integrated and Analog Computer. ENIAC was very interesting. This computer was made out from bulbs. These bulbs, as we all know, are incandescent bulbs, fuse quite a bit. So to reduce their fusing, essentially air is taken out of these bulbs, and they're often called vacuum tubes. You can still see some of these vacuum tubes if you search for them on the internet. These are very much like bulbs. If they're on, then they're hot, obviously. If they're emitting light and heat, and if they're off, then obviously they're not emitting any light or heat. That's a 0. on is the one. Interestingly, just as a snippet, the name software bug or hardware bug started there because bugs, flies, mosquitoes will get attracted to these vacuum tubes because of light and heat. They'll touch these vacuum tubes and they would die. And then once in a while, they'll end up short-circuiting ENIAC and similar analog computers. That's how, because they short-circuited it, the system would go down. Some engineer would have to go and restart the system again, fix the problem and restart the system. And that's how the bug came around. And today, it's a common to say software bugs or hardware bugs. Anyway, silicon-based transistors came around in 1960s. ARPANET, which was started by the Defense Department in the US, became Internet, World Wide Web, solar electricity cells, smartphones, and so on. The most important part was electronic communication, which was both in form of wireless and wireline, broadband cables, and then the wireless in terms of wireless communication. And of course, central processing units, which are so common today that we don't even know where they are. They may be in our washing machines, in our smartphones, and many others. Yeah, so this is what happened in the first three industrial revolutions. Now, the key inventions of the fourth industrial revolution is quite a few. One of them is Internet of Things, a very, very big thing which is already doing wonders for industrial IoT industries, for production industries, for manufacturing, and so on. You have machine-to-machine interaction, you have machine-to-human interaction, and you have basically Internet of Everything, where machines and humans talk. Already happening, will begin to happen even more so. The fourth industrial revolution, in our view, started in 2011, just when the third ended. And some of the other aspects are, of course, we have inventions coming because of climate change. The Earth has already warmed up by about 0.6 degrees, and the worry is it may warm up by 2 degrees, and there is a lot of inventions going on in that direction. Blockchain, which I won't go into more detail. Gene editing, basically cutting a gene in at a very defined place, which was the original science was created in 1980s, but then it was Kapyante and Diotina who showed an economical way of cutting genes very, very quickly and efficiently. Driverless cars were still far away, but a lot of progress has been made. And so has progress been made in mixed reality, virtual reality, augmented reality. Again, metaverse, still not there. Most of these inventions are in their early stages, their, I would say, adolescence, but will happen soon. Quantum computing, a lot of discussion about quantum computing going on. Typically, quantum computers today work with qubits, very much like classical bits, but have many more properties, quantum properties. And the only problem is that most of the computers, in fact, the best computers, do not even have 1,000 qubits. And for quantum computers to be useful, we would need about 1 million qubits at a minimum. And therefore, it is, again, one of those inventions which is probably will take off in the next 7, 10, maybe 15 years. So, and then, of course, you have AI, artificial intelligence, which started in 1950 because of a paper from Alan Turing. Can machines imitate humans? Got to be called as the imitation game or the Turing test. And I'll briefly describe that in a minute. But very soon after 1950, there was a conference that happened in 1956 in Dartmouth University in US, and various sub areas of artificial intelligence got created, all the way from unsupervised learning to reinforcement learning, natural language processing, speech processing, audio processing, and so on and so forth. The infrastructure, as I mentioned, each revolution came with an infrastructure. The first one was steam and waterworks. The second one was electricity. In fact, that particular revolution had two, electricity and also oil and gas infrastructure got created, electricity being much more important because of electric motors and incandescent lamps and so on. You can somewhat live without a car. You can't live today without electricity, pretty much around the world. And the third one had, of course, broadband and wireless communication. The fourth one also has an infrastructure, which is data, because none of these AI algorithms or machine learning algorithms can function without having very good data. And data has to be noise-free, it has to be harmonized, has to be stored, and so on and so forth. So it's very similar to basically ingesting data and then harmonizing data, and the entire infrastructure has its parallels to electricity being produced in many ways. But of course, there are many differences also. Yeah. So this is the first one. To repeat, the first invention, the first characteristics is the invention. There are many inventions which get created in a particular industrial revolution, and they often develop on top of each other. The second characteristics is one of these inventions becomes pervasive, and so in the first one, for example, it was the steam engine, which became pervasive. In 1780s, it was being used in boats, railroads, textile mills, and so on. Started in 1718, by 1840, Stephenson had used steam engines to create a railroad, a railway with tracks from Manchester to Liverpool. And similarly, in the second revolution, it was the electric motor. There are typically, right now, there are more than 3,000 electric motors worldwide. There are probably 4 or 5 running in each of our offices or rooms without us knowing it. Maybe one in our PC, one in the fan, and so on and so forth. The third one had CPU, or the central processing unit, or just simply a processor. So that's as I mentioned earlier, in our washing machines, in our refrigerators today, in smartphones, and so on. Excuse me. The fourth one is, of course, the AI in the fourth revolution. AI today, as I mentioned, already has more than 1,000 use cases where it can be used. Everywhere, the machine learning algorithm is slightly different than in other places, and it's being trained on slightly different data. So it's becoming pervasive, very much like motors are, and it will become even more pervasive. In fact, our analysis is that today there are only 1,000 distinct AI systems, and they could easily be about 100,000 distinct AI systems by the year 2050. So going to the third characteristic, every revolution created a new infrastructure. To run steam engines, you needed steam and waterworks infrastructure. To run electric motors, you needed electricity infrastructure. And to run CPUs, and for CPUs to talk to each other at a far distance and to talk to humans, you needed broadband infrastructure. The interesting part is that these infrastructures eventually not only help those pervasive inventions like the motors, but they helped others also. For example, with the electricity infrastructure, not only were motors running, but electricity was being used for incandescent lamps and so on. So the same we will see in the second invention, as I said, electric motors, and the third one, central processing units. And they led to many other inventions also. The fourth one has data as the infrastructure: production, transmission, cleansing, harmonization, and use for improving AI algorithms, and will improve other inventions related to healthcare and climate models. So when you have data, it's not, once you have a very good cleansed data, which is can be used data which doesn't have too much noise and it's reasonably good, then you can not only use it for AI algorithms, but you can use it for healthcare models, for biological models, for crop prediction and crop efficiency of crop creation, yield, crop yield, and so on, and of course for climate model and physics modeling. So the data itself, even though it is has become ever so more important because of AI algorithms or machine learning algorithms, is now going to be also driving other inventions related to healthcare, climate models, physics models, and so on, which may not require any AI algorithms, or it may be a combination of both AI and non-AI algorithms. The fourth very, very important characteristic is technology takes time. Even the best inventions have always taken time before seeping into the society. For example, the steam locomotive was first invented in 1804. It was improved in 1830, and as mentioned, Stephenson showed first trains which ran on steam engines, running from Liverpool to Manchester and back. But it really became useful for the society. It began to had mass adoption only 4 to 6 decades later. In fact, most railways went bankrupt most of the during this period, and I'll come to that as part of the fifth characteristic. Similarly, if you look at electricity, Thomas Alva Edison, started his first electric plant in upstate New York in 1882 near Buffalo. There was a lot of water and a lot of falls. So he used the falling water to create the plant. But only half of the homes had electricity in 1925. So on one hand, you can see in the first industrial revolution, it took about 4 to 6 decades. In the second one, it was about 4 decades. And then if you look at actually cell phones, they were invented in Motorola in 1970s, and they became popular only in the 1990s. Similarly, internet, DARPA internet was effectively, if you look at the email system, it was invented in 1970s and became popular only in late 1990s. So the amount of time that is taking for these inventions to filter down is reducing, but it's still not zero. And that's a very important point to note. The technology takes time before it seeps into the society. Why does it take so much time? First, you need a lot of infrastructure improvements. For example, for railways, you needed to put railway tracks. For electricity, you needed to create electric generation plants. And as probably most of us know, a 1 gigawatt plant today costs somewhere between $3 and $4 billion to build one. So you need a lot of capital infusion. Secondly, if people have already made investments in previous technology, they do not want to immediately make investments in new one. If I just bought a car 5 years ago, the likelihood of my buying a new car, unless I'm a car enthusiast, is quite low. The third is, by and large, humans are humans. If it ain't broke, don't fix it. I mean, it's moving on. Things are going well. Why do I want to fix it? Similarly, generally firms believe, look, I've done very well with what I have. Let me continue doing it. What got me here will get me there. Therefore, you need new firms, startups for creative destruction. Humans are generally risk averse and concerned if the invention fails. Imagine a middle tier engineer or a middle tier manager taking a risk with a new invention. If the invention works, then the best he'll get is a pat on the back, or she will get a pat on the back, and perhaps a little amount of, maybe some amount of money as a bonus. But if it fails, he or she could get fired. Also, workforce may need to be retrained or upskilled. And government needs to change regulations. For example, when airplanes came, before that, actually, people, when they own land, they own everything above the land, all the way to the heavens and all the way down. But once the airplane started flying, the restriction, if I own land, I could only own about 300 feet above land and in the air, and even lower in the ground. And then, of course, it takes time for consumers to adapt. depending on the invention. Some inventions are easier to adapt, some are harder to adapt. Many of the older people, especially in places like India and in the US, still are not using smartphones or internet or even WhatsApp. So these are 8 reasons. I mean, and I've been guilty of it while Mr. Mohan talked about my starting a company called the ValueServe, which was a knowledge process outsourcing company. And at that time, I wrote this paper that he was talking about in 2003 on knowledge process services. And I was also very, very enthusiastic and said, oh, by the year 2012, 13, at least $12 billion worth of business would have moved in knowledge process services from the rest of the world to India. And the reason, because India is 1/4 the price of the world and provides similar kind of work, if not better. But because of these reasons that I mentioned, indeed, only 1/3 of 1/4 of that work moved to India. So this shows that technology takes time before seeping into the society. So that's the 4th big characteristics. A lot of research has been done in this area. This one is from Pew Research, that the rate of productivity once the invention goes in becomes much bigger after the invention has seeped into the society. So, for example, although the second industrial revolution was ended in 1914, was from 1870 to 1914, actually we saw, or the human society saw more productivity increase during 1930 to 1970. So you can see the dark blue chart bars showing higher productivity in the system. Yes, and there has been quite a bit of research done. Now, this is the very interesting thing, that it takes time for even the best inventions to seep into the society. And this actually causes hype cycles. For example, we had hype, and I'll go through some examples of hype cycle. But of course, the latest one that we know was the hype cycle in 1999-2000, which was a dot-com telecom boom cycle. 1995, the US government had opened up the telecom industry completely and started giving out licenses. $500 billion were put in for broadband cable and telecom and wireless systems, wireless towers, and the entire system. Where people were saying, oh, if we build it, they will come. But they were so expensive, nobody came. So the hype got created. How do hypes get created? First, inventors become very excited because obviously it's a new invention. We're seeing this with AI. From a commercial perspective, I mean, it's a new invention. It'll change the world. The world will be different, both from a commercial and a social perspective. Once the inventors get very hyped up, they change the corresponding investors get all excited. They begin to pump in more money, which is very important because you need a lot of money to make many of these inventions work. As I mentioned, you need infrastructure for data, for electricity, for steam, and so on, for railways. Once the investors get so hyped up, then gradually the media, the paper, newspapers and magazines get all hyped up. And then the public get hyped up because they begin to buy stocks. So that is the general way of all the hype that begins to happen. And of course, it takes time for these technical inventions to actually seep in. And this hype is always very interesting. And we are seeing that even today. Every time you tell people, hey, it's hyped up, they will say, this time it is different. Every time is this time it is different. And of course, think tanks, strategy companies, and people running businesses have underestimated. I gave my own example by a factor of 2 or 3 as to how long it will take technological advances to affect the human society. As I mentioned, we had predicted that by year 2012, about $12 billion worth of work in knowledge process services will move to India. Actually, that hasn't happened until now. And my feeling is it will probably happen only by 2030, and by which time AI will be a factor in it anyway. So pyramid schemes, because of the hype, pyramid schemes get created, then the hype doesn't pan out in the short time, and therefore you have a bust with investors losing money. So here are some examples. In railroads, 1880s, 70,000 miles of railroads and stations were constructed in the US. In today's money terms, about $60 billion was spent. In 1890s, and they said, look, if we build, they will come. And unfortunately, they were too costly. In 1890s, many of the railroads went bankrupt, depressing prices and leading to new industries. So when they went bankrupt, this is the interesting part. When they went bankrupt, actually a new industry got created. Procter and Gamble decided that it was making candles and soaps at that time, and just started making shampoos. They could make these in low wage areas of the US, like Cincinnati, Ohio, and all the Midwest, and they could use railroads to ship to New York and to California, which were higher paying places. So you had transportation of goods happening because of which nobody had thought of. I mean, earlier the aim of railroads was to transport people, not for freight. And suddenly that started happening. Similarly, telegraph it went from all the way from 2,000 miles of telegraph to 23,000 in a very short period, in 6 years, because everyone thought that people would of course communicate using telegraph. There was no telephones at that time, and but again it was costly and it had very little traffic, and most of these telegraph companies failed. But what did it lead to? It led to two new industries. One was news flow. So newspapers, Associated Press, Reuters actually got created at that time, and they started sending news using telegraphs because the price had come down quite dramatically. And the second one was money transfer. Right? You could send money from New York to California to San Francisco using these telegraphs. I mean, we used telegraphs for money transfer until at least 2010. And some countries may be using even now. Yeah, broadband infrastructure is another good one. 1990s, once the government opened up, everyone thought that there would be a lot of people would be interested in using the internet. $55 to $60 billion worth of cable was laid, but it all went. They all went bankrupt, as we know, or most of them did, which led to a drop in prices, which in turn helped, because the prices now were low. 40% of US homes had broadband connections by 2006, within 6 years. Yeah. So many of these boom bust cycles happen, and not that all of them are helpful, but many of them are very helpful, and I'll come back to in a minute. I mean, there were other boom bust cycles, like canals got created, and there was a boom about canals during the first industrial revolution. There was a boom around bicycles being created in the second industrial revolution, and in the third one, or close to the third one, end of the third one, there was a housing bubble, which did not lead to anything interesting. But in general, if you look at it, these boom bust cycles are very good for society. As I mentioned earlier, and I'll go back to that particular statement again. We need a lot of capital infusion for making many of these tech inventions successful. Yeah, and what happens in a boom cycle is a lot of capital is invested. So in fact, for example, in railroads, as we discussed, about 60 billion was invested. In in broadband cables alone, around 90 million was, 500 billion was invested between wireless and wireline. So that is the good thing that comes out of it, that some of these hype cycles are good for society because of the investment that was made. Because without that investment, these inventions would not be successful. And not for all, but for many. And even though investors may lose money, that's not, the society still gains out of it. But here are some of the boom bust cycles that we see in fourth industrial revolution. One of them is driverless cars. The first driverless car was started in 1977 by a Japanese company called Tsukuba Mechanical. Ernst Dickmans built one of the earliest driverless cars using a Mercedes. He basically put a few cameras, I think two or four, two in the front, two in the back, and he was able to drive it driverless on straight highways. Carnegie Mellon University and also Berkeley at that time were building driverless cars in the 1980s. Again, very, very rudimentary cars. But since they were so rudimentary, the interest in driverless cars died in 1990s. The new interest started in 2017 with one of the Google sister companies, Waymo, started driverless cars and was able to show interesting results. And the boom then started. Morgan Stanley actually valued Waymo at $175 billion, which was 1.6 times that of General Motors plus Ford plus Chrysler combined. So you can see, they just thought that this was the next best thing next to bread. This hype led to about $100 billion being invested by the investors in 80 companies. Driverless car companies, driverless vehicle companies, which were driverless truck companies, driverless car companies, and so on. But unfortunately, this boom did not last because the driverless car business is a pretty hard problem to solve from a computer science perspective. So by 2022, 10 companies were acquired by the others. Pretty much all driverless truck companies went bankrupt, and Waymo's valuation is currently probably around $20 billion. So instead of some 175 billion, it's sitting at 17.5, about 10% or maybe 15% of the original one. The second one you may remember was Metaverse. That's how Facebook changed the name to Meta, because Mark Zuckerberg thought Metaverse was the next big thing. And so did, to a certain extent, Microsoft by buying one of the game engines, although it was not probably as excited about Metaverse as Mark Zuckerberg was. Another $120 billion was spent in. Again, Metaverse is a pretty hard problem, and therefore the boom went quickly bust. So, but once these inventions actually seep into the society, their effects are much more than anticipated. I gave the example of railroads, that Procter & Gamble and Sears essentially came into light because they were able to use railroads for freight, transporting washing machines and transporting soaps and candles and shampoo, and of course later on oil and coal using railways, which was not the original intent. Similarly, using telegraphs, money transfer and news transfer occurred. We know what has happened with the internet. Nobody in 1996, I was still at IBM Research, we used to write 10-year outlooks, showing how in 10 years, how technology will improve, how it will affect the society. We never anticipated that in 10 years, there would be a starting of social media, which will be both good and bad for the society. It will create fake information on one hand, and it will get people together, connected much more. Similarly, with smartphones, smartphones is not a new concept. BlackBerry started it, but nobody thought that with coming of an iPhone and similar smartphones later, people would be so addicted to it that usually on a dinner table these days, rather than people talking to each other, they're working on their smartphones. So there are a lot of unintended consequences and many new things get created. One of the new ones in terms of inventions is coming out partly because it's building on the other inventions are flying cars, which may become actually available in 10-year time frame. So these are the first six characteristics. Let me quickly move to the seventh and eighth characteristic, and then I'll stop for questions if there are any. Every revolution has winners and losers, both in terms of people and in terms of countries. For example, before the steam engine came and the spinning jenny came, people were actually knitting clothes. They were actually weaving clothes. And suddenly with coming of the engines, these steam engines and spinning jenny, these people lost their livelihood. And therefore this Luddite movement started. They were very worried about their jobs. They even ended up going to some of these shops which had machines and ending up breaking those machines, to the extent that the UK government had to send police and army to quell this Luddite movement. On the other hand, seasonal farm workers who were only getting business or work when there was farming season or when they had to sow seeds, now began working all year round and became more wealthy. Negative side again, because the industries needed so many people who were youth and orphans, who were working long hours and often dangerous jobs, going into mines, getting killed. There was a housing shortage in 1800s, in mid 1800s, overflowing sewage with gutters. The Thames River was probably more polluted than today's Ganga and Jamuna are in India. And within a couple of generations, many citizens improved in terms of their wealth, in terms of their well-being, but not all. And that led Karl Marx to write Das Kapital. So such a massive change occurred because of these revolutions. I mean, a whole new political system or social system got created because of Karl Marx writing Das Kapital, the haves and the have-nots. So everyone basically had an interest. They either gained or they lost in the whole process. I mean, that's what revolutions are about. They upend the status quo. Countries were no better. India and China, which provided about 47% of the world's GDP in 1700, they did not participate, they did not partake in any of these three revolutions until 1970s for sure. China started opening up its society, its economy to the world in 1974, India in 1993. And their GDP share of the world dropped from 47% to 8% by 1973. In other words, the countries that actually participated and took advantage of these three industrial revolutions saw their people become more wealthy, whereas those that did not partake in these revolutions saw their people becoming poor. Then, obviously, there were people who lost jobs, as I mentioned about artisans and weavers, and there were people who became more wealthy. This particular revolution is no different. The only thing is that because these things take time to go deep into the society, yes, jobs will be lost because of AI and because of data science, but it's not happening tomorrow. There was a very famous, influential paper from Oxford University in 2013 by two professors, Frey and Osborne. And they did all the right analysis, very similar to that was done by a similar paper in Berkeley earlier on in 2000, and was done by us regarding knowledge process outsourcing in 2003. And using that analysis, they showed that 47% of American jobs are at risk due to AI. This was 2013. And so far, they were absolutely right. 47%, whether it's 50 or 45 is always debatable, but 47% is a reasonably right number, are at risk. But what they said next is where they went wrong and may happen in next decade or two. Now, you see, this was 2013. 1 decade has already gone by and we've hardly lost any jobs. And our analysis shows that even by 2033, we'll probably lose no more than 3 to 4% of these jobs in the US, which is the most advanced country and will probably have the most jobs lost in the beginning. Jobs will be lost. A lot of jobs will be lost by 2050. But there are some other very important tectonic shifts that are happening in the society. One of them is aging and slowly growing population. Total fertility rate is the number of kids a woman will have in her lifetime. Total fertility rate for a country like India will be the number of kids on an average a woman in India will have in her lifetime. If the fertility rate is 2.1, then the population effectively stagnates. If it's greater than 2.1, it grows. India has been greater than 2.1 for almost 2 centuries at this point. But the first time India became less than 2.1 in total fertility rate was about 2 years ago. 55 countries, India will not lose population, but its population will become older because India's age expectancy right now is about 70, and within the next 15 years, India's age expectancy is expected to be around 80. So there will be more people living who are the older people will be living than they're living right now, just like what has happened in China. This is happening around the world. If there are more aging people and overall the working people as a percentage is smaller, then we will need AI and robotics to help us. It's just a fact of life. So the loss of jobs due to data science and AI may actually be a helpful thing for us because as our analysis shows, by 2050, we would have lost about 400 million jobs worldwide to data science, AI, and automation. But on the other hand, we would need more than 400 million jobs because we would not have enough humans working. So there will be new jobs, of course, created for combating climate change. There will be new jobs created because of aging population. There will be many more jobs created for healthcare workers. And of course, there'll be jobs created in 6 emerging economies. So these will be the winners and losers in the 4th industrial revolution. But the other tectonic shifts in the 4th industrial revolution are as important, like aging and slowly growing population, as AI and data science. I won't go into the types of jobs that will be created. Let me just end with the role of government. Each industrial revolution, the government had a role to play. And there was different roles in different revolutions, but governments never sat idle. For example, in the first industrial revolution, the UK government actually put tariffs on Indian clothes and Indian cloth, Indian cotton, and so on. Raw cotton was allowed so that they could spin it, they could weave it in UK and sell it to the rest of the world. But Indian cloth had a tariff on it, had a custom duty on it. In the third industrial revolution, the US government was at Cold War with the Soviet Union and spent a lot of money on R&D, and that led to, of course, ARPANET and internet. So the likelihood is quite high that the governments will play a role in the 4th industrial revolution. What is not clear is what kind of laws should the government generally bring out. And because that is not clear, my hope is that the governments wait till they bring out new laws, because it could be even more detrimental than than bringing out laws which actually work against human society. Also, different jurisdictions will treat data and AI systems differently. A place like China, to a certain extent India, may use video cameras to detect speeding violations on a highway, whereas another system, another jurisdiction, like many places in the US, will say, no, we will not use video cameras on highways because we're taking pictures of people, and if it goes into the wrong hands, that is loss of privacy. So some will overprotect by stressing individual rights. Other may emphasize communal benefits and exploit both private and public data. First may lose out some critical insights because they are not getting enough data, whereas others may lose individual rights. So even prominent scientists and others may start taking sides, like Elon Musk and Steve Wozniak have said in the past, no longer, but advocated a 6-month pause on improving AI algorithms. Italy temporarily banned ChatGPT, and this will continue off and on. But my hope is that at least for the time being, as laws are not created till we understand the magnitude and the breadth of AI systems and what they can do and what they cannot do. So we'll see how it all plays out. So just to summarize, industrial revolutions have many key inventions. One invention becomes pervasive and uses an infrastructure. In this case, it's AI. The second invention helps in creating an infrastructure, which is data. In the fourth industrial revolution, technology takes time seeping into the society. Industrial revolution creates hype cycles, which are good for the society because you need a lot of money. Driverless vehicles hype may end up in solving a very hard problem, as an example. Once inventions seep, their effects are more than anticipated. This will definitely hold for the fourth industrial revolution. Jobs will definitely be lost and gained due to AI systems, not in the immediate future, but over the next 20 to 30 years. But then fighting climate change, aging and slowly growing population, and emerging economies will offset some of the jobs lost, especially aging and growing population, a slowly growing population. And governments will need to play an active role in this revolution. Otherwise, countries' GDP growth rate may start declining. But what role will they play is not clear. So let me end there, stop sharing, and answer any questions that you folks may have. I have gone on for, as I expected, for 45 minutes. I give it back to the organizing committee and to any questions that people may have.
Yes, sir. Yeah, so far, no questions have been raised by the participants. Dr. Akila, any questions from the YouTube?
Let me ask one question, sir.
Yes, okay, sir.
Basically, the fourth industrial revolution we are characterizing because of the data revolution, right? So
data is like electricity. Electric motors is equivalent to AI. That's how.
So earlier we used to have that economic divide. Okay, now because of this, the data, we have digital divide is becoming more and more pervasive. So how we are going to address the digital divide, particularly in India? Okay, let me come with this one. When the COVID problem started, all of us, we moved to online education. Okay, but there are packets of country which never had facilities like the penetration of communication infrastructure, and even having mobile access. Power was not there, so that way the people suffered a lot when compared to the. So this when you are going to over depend on this data-based revolution, how this divide will it have a further impact?
You're absolutely right. Not only will there be a digital divide, there will be also a stronger economic divide, because those who are more educated, who have more access to knowledge, to information via internet, via other means, which are all reliant on data and on AI, they will also be the ones who will be making more money. So actually, the have and have nots will become further apart. And it's not only an issue of India, it's even an issue in the US, where 50% of the population basically lives from paycheck to paycheck. US, on one hand, is the richest country in many ways in the world, and both technologically very rich and financially very rich, and yet 50% of the country lives from paycheck to paycheck. Now, these people will not have, given that education is expensive, these people will not have the means to educate themselves or educate their kids. And therefore, the digital divide will lead to a very strong economic divide. And that is definitely a concern for this generation. I think the Gini index, as it's computed by the economists, is probably going to become worse.
And some comments on information warfare, which is likely to be this one.
No, sir.
It's already happening, and the problem with we did not cover deep learning networks and large language models and transformers. I think this warfare will become much worse because all of this will get exacerbated because of transformers and LLMs, which are both more prone to cyber attacks and can actually create cyber attacks.
And also this particularly that robotics and the drone technology and all these things are having going to have some negative impacts. Like already, Israel is deploying the AI and the drones, on a selective basis and targeted. So this way, are we heading ourselves to the Third World War, or what is likely to?
See, AI, from that perspective, as I write in the book, AI is a tool. It's no different than nuclear fission. I mean, you can use nuclear fission to produce nuclear energy, which will produce electricity. You can use nuclear fission to bomb people, which we did in Hiroshima and Nagasaki. Similarly, AI is just a tool. It's neither good nor bad. They're just machines. So, one can even argue about fire. You can use fire to cook and do all the good things for human society. You can also use fire to burn down a house and kill people. So I think, yes, definitely drones, if we use drones, if you use it for military, it's really going to be a bad thing because we do not know how drones will function because AI is unexplainable. But again, I look at it from a general perspective of the past revolutions. Almost all inventions are tools, and it is up to humans. Eventually, AI is neither good nor bad. It's just humans who are good or bad. We decide to use it for better or for worse applications.
Okay, one more question is about the over-dependence of generative AI. Of late, the people started over-depend on generative AI information. So,
Yeah.
which to a great extent, even the veracity of the information provided by this solution is not up to the expectation, or accuracy levels are question mark. So what will happen to the new generation, which are forgetting about the conventional method of learning, but adapting to the new Gen AI based learning? What will be the future of these people?
So my own view about that is that this is a boom cycle which is going to go bust in the next 3 years. That when people began to realize that AI does not produce the correct information, they call it hallucinations. Actually, hallucination is the wrong word. From a neuroscience perspective, they should be calling it delusions because it's not sensory in nature. But forget about the actual words being used. But once people realize that it is not as it is hyped up to be, my feeling is that there will be a fair bit of bust that will happen in the next 3 years in this regard. So I'm not that worried about people using LLMs and generative AI to teach their children.
No, but the knowledge what they gain could be wrong, right?
Yeah, exactly. And that's why I'm saying that there would be a kind of a setback for LLMs and generative AI, that people will stop believing in it because of the misinformation that these systems create. And therefore, it will not be used as much as it is being used today for creating knowledge or for learning.
The model is not yet mature, sir.
It probably may not get mature. I mean, it has basic limitations that it may not get any more mature.
The limitation is data, the information.
Yeah, and also that the fact that we do not know machine learning models, we cannot explain them or interpret them.
And then because of this database economy, geopolitics also becoming an issue. Political like China and US even start with, in fact, the supercomputers, what recent that top 500 list doesn't have, in fact, there is a decline in terms of number of supercomputers from China. Once it was number 2 in terms of supercomputers what they were, but they are not declaring. So, which means that there is some sort of internal, people are not coming out openly with the information. And will it have an impact? What type of impacts are is likely to?
I don't think that has anything to do with the fourth industrial revolution. I think that has to do with basically more economics than anything to do with fourth industrial revolution. China has closed its economy. It's using its government to partly fund its companies. Therefore, its products are cheaper in general, and therefore they're flooding the world with cheaper products. And the world beginning to realize it. I mean, whether it's US, whether it's India, that they have massive amounts of deficit. Export-import deficit with China.
Trade deficit is there.
Trade deficit. So, and that is what is causing the whole problem. I mean, that is where, where one can like Trump, one can hate Trump, but that is where the problem is coming. When you have a $600 billion deficit in the US, and it used to be as much as almost $1 trillion, and similarly for a growing economy like India, I believe the deficit is already at $60 billion. I would not be surprised that India also puts tariffs on Chinese products by 20%. So this has less to do, in my view, this has less to do with the fourth industrial revolution, with data science and with AI, and more to do with the fact that you just cannot afford. I mean, any society, any family, how much debt can you go in? Because deficit is effectively a debt. How much debt can you go in? Now, India so far has had overall, it has done quite well in terms of exports and has a reasonably good amount of money in its kitty of about $700 billion. But when you're talking about $60 billion every year, which is growing, I mean, India doesn't have a choice. UK doesn't, Europe doesn't have a choice. So that, I think, is a different issue altogether, in my view at least, than the fourth industrial revolution.
No, then any solution is expected from this industrial revolution for that?
No. I mean, again, AI is just a tool. You cannot expect tools to provide solutions. It's humans who provide solutions. Tools are tools. You cannot expect a hammer to provide you a solution, right?
No magic expected.
No, yeah. In fact, I start the book with a quote from Arthur C. Clarke, who was a sci-fi writer in 1950s, a science fiction writer, and he had 3 laws. His third law was any scientifically advanced technology is considered magic by humans. Everyone considers AI today as magic, which we can discuss in one of the future talks.
Yeah, there we go. Absolutely, sir.
Okay, if there are no more questions, thank you so much.
Yeah. But, sir, let me have the formal vote of thanks. Sir, can I go ahead, Mohan sir?
Yeah, please. Go ahead.
Good evening, all. I thank the organizing units, namely IEEE CS Madras, CSI Chennai, ACM Chennai, and HCC, for arranging this webinar today with the topic, the Fourth Industrial Revolution and 100 Years of AI from 1950 to 2050. We sincerely thank Dr. Alok Aggarwal, founder and CEO, Scry Analytics Incorporation USA, author of the book, The Fourth Industrial Revolution and 100 Years of AI, 1950 to 2050, for his admirable presentation on the same. Dr. Aggarwal started his talk familiarizing his book written on this topic. He narrated the 8 vital characteristics of inventions we had during the previous industrial revolutions, such as steam engine, electric motor, CPU, AI, and the key inventions built in Fourth Industrial Revolution starting from 2011, such as IoT, climatical change, blockchain, gene editing, driverless transport, VR, AR, quantum computing, AI, and data infrastructure. So the next, the vital characteristic is these inventions become pervasive. A third one is creating new infrastructure that propulses the inventions. Fourth one is technology takes time before seeping into the society because of more capital infusion. 5, industrial revolution and hype cycle, which are good for society so as to bring railroad, telegraph infrastructure, broadband infrastructure, driverless cars, AI, and metaverse. Sixth one is once inventions seep, their effects are more than anticipated. 7th one, the winners and losers in the first 3 revolution, some of the active countries were able to improve GDP. For example, India and Pakistan, though they didn't participate in the past 3 revolutions, they were able to raise GDP by 47% to use labor demand. 8th one is the role of government in 3rd industrial revolution and need to play more roles in the 4th revolution. I thank once again Dr. Alok Aggarwal for discussing the question raised. I thank Mr. Linesh SanatKumar, President, Hindustan Chamber of Commerce, for his presence and supporting this webinar. And sincerely thank our mentor, Mr. H.R. Mohan, Chair Events IEEE CS Madras, who worked meticulously to bring speakers covering multifacets of computing technologies for the benefit of our members. I'm thankful to the participants who joined us in live Google Meet and YouTube live streaming. I thank the event team members from organizing units for their support in arranging this event. With these warm words, we move to the end of today's event. Thank you all.
Thank you.
Yes, sir.
Thank you, sir. Thank you. Have a great day, sir. Have a
You
great
too.
day. Thank you a lot.
Thank you. Bye.
Thank you, sir, and have a good day, sir.
Thank you, you too. Bye-bye.
Bye-bye, sir.